So my name is Erik and this is Soeren, and we are both from CEPT. And in this hack, we tried to combine the CEPT Retina and the CLA. And people who have been at the last hackathon know probably the fox eats rodent. And we tried to extend it a little bit. Our main goal here was to get more exposure to the CLA, to get to know it better, to understand it better, and also to test drive a new set of retinas that we have developed, which have some special properties. And so for the first experiment, we hooked up the CLA. It's just one region, and we just use the temporal pooler. And we feed sample sentences into the CLA. And the sentences are of the structure, for example, Marie Curie, B, physicist. And then we also had like a second class, singers. So sample sentence would be Madonna, B, singer. And the way we feed this into the temporal pooler is we ask the CEPT Retina for the semantic fingerprint for Marie Curie, which is an SDR. And then we pass this SDR directly into the temporal pooler. And this was interesting for us because the semantic fingerprints of persons are very complex, because as you can imagine, a person has many different contexts in which it can appear. And the same goes basically for the term physicist. Physicist, you have like the profession itself, and then you have like exposure of physicists in movies, where a crazy physicist wants to build a doomsday machine. You have historical aspects, you have university teaching aspects. So they are very complex and very spread out fingerprints. For example, this would be the semantic fingerprint for a physicist. And you can see, if we visualize it, that it's very much spread out over the semantic map of our semantic fingerprints. So the semantic fingerprints that we use, they have topology. And if bits are more in the upper right corner, then they will relate somehow. You can't say exactly what it is. For example, the big blob on the right, that seems to be like the physics or physicist area. And from the pattern of the bits, you can see that this is very spread out and applies to many different contexts. And so the first thing we did or wanted to test was to feed these sample sentences in. So you can see there's about 20 physicists and a little bit more singers. And I can quickly run this. And what I also have to say, the SDRs we used are 64 times 64. So the original Fluent ones, they were 128 times 128. So we have a lower number of columns, and that's why it's working much faster for us. And then these at the bottom are the predictions. So, and these are all persons that the CLA has never seen before. You can see that up there.
Sure?
Yeah, I'm sure. So it's like Katy Perry, Robert Oppenheimer, Don Henley. And it's quite good.
Are there any singer physicists?
Maybe. Yeah. Yeah, no, it's actually quite, because for example, Cecilia Bartoli, I didn't know her. Soeren, he's very much into classical music, but the CLA already knows that she's a singer. And so for the next one, we tried to take it a little bit further, and we said, let's introduce I just run it anyway. So let's introduce something
Like the second verb.
A second verb. So here we have just 4 sentences, that's all, and we say Eugene Wigner like mathematics, Wolfgang Pauli like mathematics, so they're both physicists, And then we take Katy Perry like fans and Nancy Sinatra like fans. And then we and then we run this again, the like.
Just a very few sentences.
Yes. So it has like the corpus of the input data of all the singers and physicists, but on top of that now we place these 4 sentences with the expression of Wolfgang Pauli likes mathematics and Katy Perry likes fans. So on top we have like the same predictions.
So,
And then
so you only added 4 additional sentences with a
exactly.
line.
And I think well, I was very surprised that I only had to add 4 sentences, but I think there's already a lot of connections represented in the CLA. But what really surprised me, so here we have people, for example, Eminem, the CLA has never seen him in any context. He's not in the sentences. So it can already say Eminem be singer and Eminem like fans. Or Albert Einstein, he's not in the sample sentences. So Albert Einstein be physicist, and Albert Einstein, I think he's down here, like mathematics. And it seems to be, or Buddy Holly, he's not in there. So I'm surprised already that you get something like Max Planck. He's one of the Max Planck B physicists. So I'm surprised already that you could deduct that also it has never seen Max Planck in the context or in a sequence with mathematics. It can say Max Planck like mathematics.
Has it seen mathematics in the training corpus? Is mathematics a word?
Yeah.
A word,
But
yes.
some other physicists liked mathematics, so
Yeah, so
it
only Wolfgang
assumes
Pauli
that
and Eugene
because
Wigner.
Max
That was the
Planck is a
only two
physicist,
sequences.
he likes
Cool to see
mathematics.
the second and third similar word lines.
It'd be cool to see not just mathematics and physicists, but what's the second most
Exactly.
likely word. See
Exactly.
if it's
The full
generalizing
list.
in that sense. The full list of similar terms to the
Exactly.
SDR that was predicted.
Do you think without changing the training set, we could see what Barack Obama would be?
Yes, we can try it then afterwards. But let me go to the next step, because yeah. So this was the status there, and then we thought, okay, let's try some more. And what we do in the last one is that we add some abstraction. So we go to physicists and mathematicians, and we want to see what they like. And we also introduce actors and Tom Cruise. And
That's a random one. So that's in the test set?
no, that's like when we ask for the predictions.
And then a member of the category.
Yeah, so it has never been exposed.
Why did you come from National International? He's an actor.
Sorry?
Oh, I see. Oh, I got it. I got it. I got it.
Those are test sets, not training sets.
Yes. So the training set is exactly the same as before, with the like, the 4 sentences of like. Okay. And now we have actors like mathematics and Tom Cruise like mathematics. And initially I was a little bit disappointed, but then I was thinking it didn't have a lot of exposure. When you think about how little or few sentences the CLA saw, and in my mind, of course, actors are more closely related to singers than to physicists. But for the CLA, maybe that's not true.
You got it, but it's really not that. It's really the actors are related to which people, right? Isn't it more like it's which actor? It's never seen a physicist as the first word here, right? So I mean, you're really saying if I give it actors, it has to relate it to the names you saw before, right? There has to be an overlap between actors and the names, you know, Nancy Sinatra or whatever.
Yeah, the CLA's never seen actor
No.
at all. So you're
Yeah.
using a term, a CLA.
Yeah, but for it to do the right thing here, the word, the SDR for actors has to overlap substantially with the SDRs for the people who are musicians, actually. And that's interesting. I don't know how much you'd get an overlap there. It'd be interesting. Did you say singers like Because like Nancy Sinatra and Katy Perry are singers.
Exactly.
Famous people, like actors.
Well,
No,
you can say they're famous, but they're also singers. So you're getting out to smaller and smaller overlap in meaning, I think, right?
No, but the thing is that CEPT doesn't actually understand the difference between an actor and a singer. Human beings do, because they know that singers also.
Yeah, but it knows the overlap between the word actor and Nancy Sinatra and the word singer and
Yes.
Yeah, sure, but the point is that actors that are mentioned on Wikipedia and singers that are mentioned on Wikipedia share an awful lot of things that have to do with being famous because they have a page on Wikipedia.
But so is Albert Einstein famous.
Exactly.
Correct, yes.
But maybe
so
I continue.
like the thing is that, for example,
because
no, but the thing is when you see the demo that you've just done, the problem is that human beings looking at what you've just been doing go, well, of course that's going to happen because, of course, Wolfgang Pauli likes mathematics, right? But you've just given a computer system with some sort of memory lookup thing that produces SDRs, the text of Wolfgang Pauli, the
No, I
text
haven't
of
given it the
mathematics, right? Okay,
Huh?
and it's retrieved this actual relationship between Wolfgang Pauli and mathematics that doesn't exist between Katy Perry and mathematics, right? And in fact, you've just given it Wolfgang Pauli and and it's come back with mathematics, right? And
so
unfortunately, we've now just seen so many demonstrations of this that now we're no longer surprised by how amazing this is, right?
Yeah, I'm not surprised at all. I think I understand. I'm trying to explain why actors will not do as well generalizing to other celebrities or other mathematicians. I think I can see that, but we don't really know until we look at it. You have to look at the bit overlaps between these words.
So, yeah, and concerning this, because if we, for example, now add like 3 more sample sentences with actors, so I take in Pamela Anderson, Tom Hanks, and Charlize Theron to the training set.
Is that what Pamela Anderson?
Then it got it. And the very interesting thing, and this relates directly to this discussion, is that, for example, now we had a switch of Albert Einstein to like fans. Because, yeah, I think that's what's happening, because we looked and we started to analyze, I mean, time was very short, but
We really ought to look at you ought to look at what the second word predicted is and so on.
there
I
it
mean,
becomes very interesting.
the answer to these questions is it's not whether you get the right answer, it's whether you get a good answer. And we have to remember that. So it's kind of hard to know until you see some of the other alternates. But Albert Einstein was a very, very famous guy. And he didn't shy away from his publicity. And he was feted by kings and queens. And so, he could definitely be up in the fans category. You never really know. We can't, we can always ascribe meaning to these things, and we have to be careful about that, not to do that. But that's really cool.
Yeah, I have to say I'm really hooked now to the CLA. It was the first time that I really was exposed to it, and I mean, this was like an 8-9 hour hack, and we didn't know the CLA that well, and I mean, also, of course there are systems who can stuff like this, but I mean, this is a runtime of like a minute, and for that, I think it really shows the potential of putting the two things together.
Very cool. That's really, really cool. Question, a detailed question. Is the sparsity level coming out of the CEPT retina, is that been normalized in this API?
No,
so is
no,
that,
it hasn't.
So no, so
And
the temporal
potentially-
pooler is getting different levels of sparsity
Yes.
in this example.
Yes.
And it's not being normalized.
No.
Interesting. So you didn't have to do that to get good results. That's interesting.
Well, we were discussing this earlier in the week, and our original reaction was, well, you have to get it normalized to a certain percentage, but then Subotai pointed out that maybe not, and then we thought about it a little bit more, and we said, yeah, given it may not actually care too much. We thought it would, but maybe not. So it might be more robust.
Yeah, maybe. Yeah. What will happen is if let's say physicists had, or if fans had very high density, like 5%, and mathematics had very low density of 1%. And it might kind of predict fans, but even kind of predict fans might overload what mathematics is. So you have to be a little careful.
Yes, yes.
It would definitely be safer if it was all the same sparsity level, but it takes more thought.
Yeah, so I just wanted to say that I was really thrilled by this. I mean, it is definitely not a scientific analysis by looking at those results, but
No.
still it sort of behaves how one would expect it intuitively. So you don't need to sort of think about this for 2 hours to come up with some sort of plausible internal explanation. But the really fascinating thing is that we are looking here at things like 10 examples of this, 3 additional examples of that, and it already looks, so to say, very interesting. And it seems to sort of cross-link aspects that it did not see linked together before. And I think that this has to do with the fact that we, so to say, have a very rich semantic data that we are working with. I think that is what is to me, the most important outcome. So if one would try to just make a simulator of this simulation using traditional NLP things, you would need like 1,000 times the amount of data, and it probably would take hours to actually pipe the whole data through. And again, it would not give like a clear statement like this. So I find this really unexpected even. I mean, unexpected, it's better than I thought.
You said you're hooked into CLA. I think this gets me really excited about CEPT in reverse, because a lot of these sequence learning things, we use numbers and things like that where they don't have that much semantic overlap between the different patterns, but with language like you guys have done, there's a lot of semantic overlap between things, so there's a lot of scope for generalizability, which there isn't in a lot of other kinds of problems.
And
so you get a lot of interesting behavior here due to that generalizability.
yes, and one thing that I forgot to mention, so in order to get this running, for example, I said at the beginning that physics or physicists is a very distributed semantic fingerprint. So the one trick that we did, which differs from Fluent, is that when we enter the third fingerprint, we take the and between the person and physicist or singer, because we want to condense the fingerprint only to concentrate on the profession part, so that we can say, okay, this is a physicist. Because physicists, they are all over. And for example, this is the fingerprint for physicists, and if I take the and between Max Planck and physicists, you can see that a lot of the semantic bits are removed.
You know that was necessary?
That is necessary.
If you didn't do that step, that it didn't work well?
Well, if I don't do the step, the first stuff works. Max Planck B.
Yeah.
But then the inferences which come on top of that, what does Max Planck like? This doesn't work anymore.
So what do you do with when you fed in that example where you fed in Tom Cruise? How did you know to? In that case, you would want to end it with actor, but how did you know in advance what to do in that case?
No, I just always end like the profession with the person. But this is just like to help me within the hack to create a more focused fingerprint which only represents the profession.
So hopefully that would automatically be done if you had given it more context.
Giving it more context.
Then the
or
CLA
use the
would
CLA,
would pick the bits that represent
I think so
by the
too,
context,
that
maybe.
with more context and longer learning time, that this would happen automatically, but it was just like a shortcut, I think.
Yeah, so in the cases where you were like testing, where you didn't know the answer and you hadn't presented the correct thing, if it's an actor, you're pre-processing the CEPT SDR for the and of the profession of the, so you're like
When
it's
I'm
hidden
testing.
from this. So Angelina Jolie, if it's a string there, gets turned into Angelina Jolie and actress.
No. Just
No?
the profession, just physics and singer and actor. But these are the pure fingerprints of Tom Cruise, mathematicians, physicists.
Maybe this was not clear. It was not about to find out what a professional person is. It was taking one person where we know it's a physicist, and we take this person as an example fingerprint to end it with the name of the profession to get only those points that are really relevant to the profession and not.
That's how you created a new fingerprint for physicists.
For physicists, that is more precise. It's so to say physicist as a profession. That would be the.
You do that just for one person?
And you can achieve this by taking a random person that is a physicist and ending it with the fingerprint.
So that's less of a cheat.
It's just the way how you calculate with the fingerprints. And if you want to be more precise with what you want to say semantically, you just take an example item and you make a Boolean combination.
Yeah, we do this quite often. Also, like we call this synthetic fingerprint. So you want to represent something. For example, you want to have a fingerprint which represents computers. So we just take like a couple of computers and we AND them. And this is then the essence of computers. They might have different bits, but when we AND them, then essentially this looks like a synthetic fingerprint representing a certain class. Exactly.
So I think the nice thing about this, and the reason why the people on the kind of NuPIC and Numenta side of things are asking so many questions about this, is because this is a classic example of, like, obviously there's something really interesting going on here, but none of us know which bits of that are happening on the CEPT side and which bits of it are happening on the CLA side, right? And that's exactly the way that the brain works. So that some of it happens on the above a particular representation, and some of it happens below a particular representation. And this is a perfect example of that, right?
Exactly. And
so the fact that we don't know which bits CEPT is going to take credit for, and we don't know which bits that the CLA is taking credit for, proves that this is the kind of way that these things work. Yeah.
Exactly. I was thinking that cerebral true on both sides, on the retina side and on the CLA side. I want to see that.
Just, you know, I hate to belabor this, but it's just dying to know the answer to this question, what you guys think. So this trick you did to basically create a more accurate representation for physicists by ending it with a particular physicist, that makes it sparser. Could the similar result have been achieved just by a sparsification step by, saying, there's various ways you can make this sparser by putting different thresholds on it? Would that might have created the same type of result?
It might have, but
I mean, this gets back to the varying. This gets back to the varying levels of sparsity in your SDRs. And I was wondering if we brought them all down to the same 2% through other means, would it might have worked better?
Yeah, it might have been, and this is more to also like what training data went into the retina, because usually when you try to sparsify without looking at the topology, then the strongest context will win. And that might have been like this, exactly this context, but it might have been also like the movie physicist, the movies context, or the fame context.
Well, it's just interesting whether, because it might, in theory, you'd think to be more context of Einstein as a scientist and fewer as a celebrity. And therefore, if you just sort of threshold this down through some way, you might end up representing more of the scientist side than the celebrity side, which is kind of, I think, what we might be doing a bit. But anyway, really, really nice.
Yeah, I mean, and just for example, the Apple example, that was one of the classic things, that most people, if you ask them about natural language, they would assume that the word apple must mean the fruit first, right? But because of the sources that are used for CEPT and the sources now in popular culture, that if you ask a 15-year-old kid about what does the word apple mean to you, it means a phone, right? Whereas when I was 15, it only meant fruit, right?
Exactly.
So the thing is that people our age now are confused by some of these things that CEPT has produced by just analyzing the statistics of the meaning of words. And so, for example, Albert Einstein, to a kid in popular culture now, is not a physicist, but he's guy who sticks out his tongue in a black and white picture, for example.
And was in some Apple ads. Yeah, we probably need to get going here, but I was just going to point out that part of what CEPT has talked about doing, and I don't speak for them, but is obviously this is what the people who wrote Wikipedia entries think about Albert Einstein, and that's biased. But the whole point here is you can build different sets of word fingerprints by different corpuses. So you put this through PubMed, you get one thing. You put it through physics letters, you get another thing. And you threw it through the patent office, you get another thing. So, and that's exactly what you want, and that's part of the power. And you can sell those differences and make some more money.